So in this lecture, we will look at the ZigBee protocol. So ZigBee is a low power wireless communication protocol that has been designed to enable automation and communication between various devices. So ZigBee protocol has low complexity and power consumption, and the primary focus of this protocol when it was designed was to support applications in home automation, industrial monitoring, and control system kind of application. So ZigBee protocol operates on top of IEEE 802.15.4 standard, and it utilizes the medium access control and the physical layer that is defined by this standard. So although the protocol is designed for higher power devices when we compare to other low power technologies like Thread or Bluetooth low energy, it is important to note that the ZigBee devices are still very low power devices that operate typically on batteries. So the history of ZigBee protocol is closely related to the development of 15.4 standard, which is why the terms are often used interchangeably. However, it is important to note that ZigBee is a specific protocol that has been built on top of the IEEE 802.15.4 standard, and it focuses on application layer communication. So what is the timeline of the ZigBee protocol? So in 2003, the IEEE released the 15.4 standard, which defined the physical and medium access layer for low power, low rate wireless personal area networks. The standard was developed to provide low power, low data rate wireless connectivity to support various applications, including home automation and industrial control systems. Next, the ZigBee Alliance was formed. It was formed in response to the growing need for a low power protocol, and it was formed in 2002. And this group consisted of companies that were working together to develop the ZigBee protocol, which would then operate on top of 15.4 standard. And the goal was to provide a complete networking solution with application layer communication. The ZigBee protocol as the specification was released in 2004. It provided mesh networking framework and application layer for devices. And since then, it has gone through a number of different iterations. So how is ZigBee stack organized? So it is organized into several different stacks, and each of them is responsible for different aspects of wireless communication and networking. So the structure of the ZigBee stack includes physical layer, the lowest layer in the stack, and it is responsible for radio frequency communication, modulation, and demodulation. And as we mentioned, it is based on 15.4 standard. The medium access layer, and it manages the wireless medium, handling tasks like channel access, frame validation, acknowledgement. The network layer is responsible for establishing and maintaining the ZigBee network. It handles tasks such as routing, network formation. Then the application support sublayer, this layer is an intermediate between network layer and the application layer, and it is responsible for maintaining and storing table information for devices, and also it provides some security services. And finally, the application layer. This is the topmost layer in the ZigBee stack where the user-defined application reside. And this is responsible for processing and managing applications and data interacting with different other layers of the network stack. So ZigBee heavily utilizes the 15.4 MAC layer for its core functionality, and it employs the same physical and medium access layer as specified in the standard. And this includes the using beacon-enabled networks. So ZigBee networks can operate in beacon-enabled mode, where the coordinator, or let's say the access point, transmits periodic beacon frames to synchronize the devices that are connected in the network. These frames may also have guaranteed time slot. So some of the devices could be given a specified slot for getting them uninterrupted access to the wireless medium, and it could be useful for time sensitive or high priority application. Then we have CSMA-CA mechanism. So ZigBee uses this mechanism for channel access, which helps it to minimize collision and overall improve the network efficiency. So how does the ZigBee network look like? So ZigBee network is composed of devices that assume roles similar to 15.4 standard. And the main components are, we have a ZigBee coordinator. So the ZigBee coordinator is a device that is responsible for initiating the network and determining its key parameters. So this device establishes the network structure, assigns individual addresses to the device, and manages the security setting. So in addition to this coordinating role, the ZigBee coordinator also acts like a router. Next, we have the ZigBee router. So these devices are typically high-power devices and are more capable than the end device, and their radios are typically always on. So you're not duty cycling their radios. And this allows them to maintain a constant communication in the network. A ZigBee router can connect to multiple child devices and one or more other routers. So ZigBee end devices are the low power and the least capable devices. This is where typically your sensor devices would be. The primary function of these devices is to interact with the environment or the user, collect data, perform some action, and receive commands. And a ZigBee end device is always a child of a router or a coordinator. And ZigBee devices typically and end devices typically save power by entering sleep mode when they are not actively communicating or sensing. So how does the topology of ZigBee look like? In older ZigBee networks, nodes were very much organized like a tree topology, which is a preferred structure at that time. So the key characteristics of a tree topology is that you have a beacon relevant network. There is super frame based synchronization, and sort of like it has structure which is similar to what we show, which is a bit of a hierarchical structure where the nodes communicate to their parent and then the parent communicate to their parent. So typically this topology would operate in a beacon animal mode where the coordinator and routers would transmit periodic beacon messages to synchronize the connected devices. Then the then basically the routing and the address assignments and other things were also sort of like put together with the beacon super frame for synchronization, and there was sort of like other details. However, modern ZigBee networks primarily adopt a mesh topology, which has become the preferred structure due to its numerous advantages. So mesh networks in ZigBee uses non-beacon enabled communication, and the main feature is that they have an always-on router. So in a mesh topology, all routers are always on devices that maintain constant communication with other devices in the network. And mesh networks allow for arbitrary communication between routers, which allows them to build complex network structures. However, there are of course also some trade-offs in having a mesh topology in ZigBee networks, that it requires higher power consumption since routers are always on device. Then typically they consume much more power than the tree topology, which can enter sleep mode, as was the case in the older ZigBee networks. And secondly, when we talk about routing in a mesh network, like similar to what we show on the slide, it can be much more complicated due to the having arbitrary connections between different routers. And this might require you to develop advanced routing algorithms so that you can efficiently route data within the network. And this of course also introduces complexity in terms of addressing, is like how do you sort of like figure out the address of different nodes in the network and figure out what the path the packet should take to reach from one particular node to another, and it necessitates a sophisticated address management system to be part of the network. So next we talk about actually ZigBee application layer. So ZigBee application layer plays a crucial role in enabling communication between the devices and the network. And one of the things is that it is organized in this server and client role. Each device can act both as a server and client, which enables flexible and efficient communication. And it is organized as profiles. So the application layer is organized such that there are predefined set of application level features and functionalities that are tailored for specific use cases. And within each profile, there is a definition for various devices or device and how they interact with each other. And these definitions specify like what is the capability of the device, and it sort of like allows it to be interoperable and communicate with other devices in the network, which might not be from the same manufacturer as well. So there is actually some analogy between Bluetooth and ZigBee. So very similar to the Bluetooth profile, ZigBee has their own profile. In Bluetooth, the services are equivalent to the ZigBee cluster, and then the Bluetooth characteristics are similar to ZigBee attribute and ZigBee command. So there are like parallels that you can draw between the Bluetooth and the ZigBee network. Finally, how does the ZigBee network look like? So you have these end devices, which are like the heater controller or a fan controller, or it could be sensors. Then they're communicating to the router devices, and then the router devices are communicating to a coordinator device. So most of these ZigBee networks are organized in a very similar manner. And with this, we come to an end of this particular lecture. Thank you.